Okay, I will start. Those who are not finished, don't worry. You can finish in all peace. But I otherwise I cannot finish, and I extended the other class also a little bit. So the first thing I want to have you look at is the map in my background, which you already saw. It's like a beautiful colored map, and the map I'm showing you here basically is the same map but with different colors, and this map represents the ecosystems on planet Earth. Okay, if we look at the presentation, we see that we have about 10, 11 big ecosystems on our planet, which goes from tropical rainforest to ice and tundra and grassland, all of this. And you see that the map is colored according to the different ecosystems. And there is one thing very striking, that here in the north, you can see tundra and alpine vegetation, and then you also see some coniferous forest. So everybody knows, of course, the more you go to the north or the more you go to the south, the colder it gets, right? And that defines the ecosystems we have. So that's the first big thing that you have to take in mind, that the proximity to the equator defines which ecosystem you're going to have. But if you look closer to this map, you see that it's not always logic what you see. Because if you look at Mexico and Central America here, you would see tropical rainforest. But if you go on the same height in Africa, you would see desert. And if you look in the Arabian Peninsula, you also see desert. So only latitude doesn't explain ecosystems, you know. There is more to it. And in fact, it's very complex. And I just want to give you, with this class of today, an idea that helps you understand why do we see tropical deciduous forest here, why do we see savanna here, why is the desert there, and why do we have jungles in very limited places on planet Earth, okay? The first thing we have to understand is that there's two big things that define ecosystem. And I already told you one is temperature. And temperature goes hand in hand with latitude. The more to the north or the south you go, the colder it gets because of the how the Earth is positioned to the sun. The other one is precipitation. So this is a very interesting graph to take into account, because here you have all the different kinds of ecosystems, and you see here, if you look on the temperature line, you see the lower the temperature is, the less trees you have, you get a bit hotter, you get pine forest, it becomes hotter, and you get like a cold desert, and if it becomes high, you get hot desert. This is because of the precipitation that's on the other axis. So what you have in many places on the earth, you can have high temperature but low precipitation, and you get a desert, a hot desert. If the precipitation goes up, you see that the ecosystem change, and the higher the temperature and the higher the precipitation, the more precipitation, the more variety there is, of course. And with the biggest variety is, of course, the tropical rainforest. Let's talk about Saltillo. Think about Saltillo. Where would we be?
Hot desert.
No, Saltillo is not a hot desert.
Wouldn't it be a cool desert?
Yeah, it's between hot and cool desert. In fact, it's in between both of these, and it still has some precipitation. So that's why it would be on the cross section of those four. And it's even fun because you can see all of that. You can see cool desert characteristics. You can see some hot characteristics, hot desert characteristics. You even see some savanna characteristics in certain parts. If you go a little bit more to Arteaga, you see some grasslands. If you think about the canyon of Chapultepec is also grassland. And if you go up in the mountains, if you go to Arteaga, of course, it changes to coniferous forest. And this chaparral also, this is a very Mediterranean issue. But if you go here in the canyon of San Lorenzo, you can typically see those chaparrals, which is like bushy vegetation. You see that a lot in the mountains here. Of course, it's slightly different than the Mediterranean one because of the air humidity, but that's a little bit what we have. And why is that? It has everything to do, the combination precipitation and temperature. And in Saltillo, it's fairly dry. In fact, we only have like 2-3 months a year that we have some precipitation. Think about it. It has been since September that it didn't rain in Saltillo. We didn't have a drop of rain in November yet. and we didn't get a drop of rain in October. I think just in September there was some rain going on, but we already have almost 2 months without anything. Okay, so now we have understood already that we have those things that we have to take into account that defines the ecosystem is the latitude, which is basically temperature, you know. Temperature is defined by latitude and by altitude, you know. Temperature goes down the higher you go, but it also goes down the more north you go. And then precipitation, you know, precipitation is how much it rains in a given place. But it's way more complex than that. Not only those factors can explain the map that we are looking at. We have to look at other things as well that define ecosystems. And the next thing that I'm going to explain is something that you know, but it's the position of the Earth, okay? The more you go to the poles, I'm from Europe, and we have very clearly 4 marked seasons. Here in Saltillo, we have like more 2 seasons, like summer and winter. I mean, I'm going to close the door, sorry. And another important thing is, in fact, that the Earth rotates around the sun, but the Earth is not like a straight ball. It's tilted on its axis by 23.5 degrees. And this causes, it's this tilt of the axis of the North and the South Pole that causes us to have seasons. If this would not be the case, we would not have seasons. It would be always the same amount of day and the same amount of night. You know that now we're getting in winter and the days get shorter, and it's all because of the axis of the poles that is tilted. It's not straight around the sun. And this has a very important consequence. That means that the Earth spins around the sun, yeah, and in the summer, what basically happens is that the northern hemisphere gets more sunlight. It gets more direct sunlight, and you see here the southern hemisphere, which is more into the shade. And this causes the days to be shorter, and it causes the temperatures to be lower. It has nothing to do, summer and winter, of the Earth being closer or further away of the sun. It has everything to do with the amount of sunlight that reaches to the surface of our planet. And if we go to the winter, which is here, you see here in the winter, if it's winter here in the northern hemisphere, Mexico is in the northern hemisphere, it means it's summer in the southern hemisphere. And you see that the northern hemisphere of our planet is more casted into shade, and the southern part is more receiving more sunlight and longer days. And this is something very important, because also this spinning and these seasons, they cause this map to look how it does. Because in these areas here in the north, you have coniferous forest, but you also have a lot of tundra, which is basically some little plants that grow on the soil. And in fact, this tundra is growing not only because it's cold, it grows mainly only because there is so little sunlight. If you're in the North Pole in summer, in winter, I'm sorry, you would have in the North Pole in the point, you would have 6 months, not 6 months, but you would have several months of complete darkness that the sun doesn't even come on the surface. And the same happens in Antarctica. And I'm from Belgium, and even in Belgium now it's winter, and I was grown up with this, but in Belgium in winter, in summer, the sun would go down at 10:30, 11 o'clock at night. Okay, it's very long days. But in the winter right now, it gets dark at 4:30, 5 o'clock in the afternoon. And the more you go north, the more pronounced this effect will be. So also the seasons and the tilt of the planet, how it spins around the sun, causes these ecosystems, and it has everything to do with the amount of sunlight and indirectly, of course, temperature, okay? In the equator, for instance, you always have 12 hours day and 12 hours night. Doesn't matter if it's winter, summer, it doesn't matter. It's always 12 hours day, 12 hours night. Here in Mexico, we do have a difference, because we're in the north of Mexico, and we do feel it now like, whoa, it's already 6 o'clock, it's dark already, I'm not used to this anymore. And this also causes in Europe certain people to get depressed a little bit in winter, because I remember when I used to go to school in Belgium in winter, I would arrive, I mean, I would leave my house in the dark, and then my first class would be in the dark in the school, in our prepa. And then when I would arrive home, it would be dark again because our prepa in Belgium, it's from 8:30 until 4 o'clock in the afternoon. So you're lucky because we have more hours than you do. Um, but I remember perfectly because I always went by bike to school, and in winter, yeah, you would wake up in the dark, and you would leave in the dark. So you would just see in the school during the day some hours of sunlight, and that's it. Okay, there is the next thing I would like to explain is a little bit why do we see deserts here on the 30-degree latitude? We have here the Mexican and the Arizona desert, yeah, the Chihuahuan desert, also Coahuila desert, the Arizona desert. It's more or less on the 30-degree latitude. Then we have, of course, the biggest desert in the world, which is the Sahara Desert. We have the Arabian Peninsula Desert, and we have here the Iranian Desert, and here on top we have the Gobi Desert. This is called the Central Asian Desert, and this is the Gobi Desert. So on the north, we see at 30 degrees, we see a lot of deserts. And in the south, at 30 degrees, we see here the Patagonian Desert, the Atacama Desert, we see the Namibian Desert, and the Australian Desert. So we see is something interesting that we see that around those latitudes you see deserts, and around the equator is where you would find the tropical rainforest. You see here in Indonesia and Malaysia, you see here in Congo and Congo Brazzaville and Gabon, you see tropical rainforest, and also here in Brazil, Venezuela, Colombia, Ecuador, and Peru, you also have tropical rainforest. Well, why is it like this? And therefore, I have to explain it with this image. And this is possibly for you the most difficult to understand, but it has everything to do with the spinning of the Earth and air currents. Okay, so do you know these games that you, ¿cómo se llama, Isali? Los juegos que giran así, como que tenemos allá en la cabaña, que giran así. Como, es un molino. You know these kind of things that you sit on it and it spins? Yeah?
Yeah.
Yeah. So,
El trompo.
¿Qué dices, Ana Pau?
El trompo.
Se llama trompo. Es que no sé cómo se llama en español, pero it's for children. You sit on it and you can spin it in the middle and then you start spinning.
No. I was talking about another thing.
Okay. Anyway, in one of these things, where do you feel the spinning the most? In the edges or in the center?
In the edges.
In the edges, of course. That's the centrifugal force. And in fact, our planet Earth also has this centrifugal force. And this causes something really interesting. Because, of course, we have an atmosphere, and the atmosphere is the thickest around the equator, because the Earth is spinning, and what happens is that all the air and all the humidity accumulates where the air is spinning the fastest. And what is the longest circumference of planet Earth you can have is the equator, because that's 40,000 kilometers. It's right here, okay? And this causes that, because the air is spinning the most, the centrifugal force is the most. So what happens basically is you get accumulation of air, moist clouds. And this is the reason why why on the equator it's very humid, it rains a lot, and you have a lot of air accumulation. For the very same reason, we see on the 30-degree latitude, we see the formation of deserts, because here it turns too slow. If you go to the North Pole, to the Nordic areas on the 60% latitude and the other 61, the air is turning so slowly that basically it doesn't move. It stays a little bit stagnated, you know? And that's also the reason why in Europe you don't see any hurricanes and you don't see these very quick changes of weather. I don't know if you have ever been to Germany or to Belgium or to France. What you usually have is 1 week of rain, and humid. And it doesn't change as fast. It's not like one day really hot and then all of a sudden it's rain. It can happen, but not that much. And that's because there is just not that much air flux, not so much air circulation, because air doesn't move so much on the poles. it moves way faster on the tropical regions. And basically what happens is the equator area is benefited of those air fluxes, and it takes all the humidity from the 30° of the north and the 30° of the south. It sucks it to the equator, and it creates like extreme humidity on the equator, and as a consequence you get extreme dryness around the 30°, and this causes deserts to exist typically on those latitudes. That's a very important reason. It's due to the spinning of the Earth and the air fluxes of our planet. Okay, did I explain myself a little bit to how that happens? Why is the equator humid, and why do we live in such a dry area here? It's just because our air is sucked to the equator, and that's why we stay behind with dry air and we get deserts, and there is not jungle here. And in fact, there is an interesting video on YouTube about Atlas Pro, and we know that because of our scientific research as well. The desert of the Sahara, this used to be a jungle, and this was like when the continents, they were moved a little bit and it was still in a different position, and the humidity would accumulate in the Sahara, then we would see there savanna or even forest, even some areas possibly jungle. So that's very interesting to understand. There is other things that are important in the formation of ecosystem, and that is ocean currents. Okay, ocean currents, you see this current is turning like this clockwise, and here it's turning counterclockwise. Why is it like that? Also for the Earth's rotation. It's because the Earth spins that you get those cycles turning in opposite positions. And in fact, I have a very short and very fun video what you can do if you want to visit the equator. And this is a real life video of Uganda, where they show this effect, which we call the Coriolis effect. How you can do that.
The water.
Yeah, the water only on some meters distance. Let's have a look at it. What they do, and the same happens in your toilet. If you go to the toilet here in your house, you will see that the water flushes clockwise. If you go to Australia, you will see it will flush counterclockwise, and this is because of the spinning of the Earth. So have a look at that, and this, what you see, the Coriolis effect, is causing air streams to be as they are, but they also cause ocean streams to be as they are. And ocean currents is very important because the ocean currents, they bring humidity, they bring rain, they bring all kinds of things that is very important. Okay. And also other things that are important is how far or how close you are to the sea. You know, if you're very far from the sea, you have also continental climates, and continental climates are of course more dry because it's more far away from the ocean. And that's typically why we have in the north of China and Russia the Gobi Desert, because it's really so far away from any ocean that there's just no humidity arriving. So have a look at this, guys. I think it's a very striking video to explain what happens with this Coriolis effect. And this effect is very important because this is responsible for the ecosystems we have. It's causing the air currents, the ocean currents, and it's causing basically weather to be as it is, okay? And that's why this is even causing hurricanes to spin in the direction as they spin. Some of you might have seen it because it went viral a year ago or 2 years ago.
Southern hemisphere. But after pouring, I have to stabilize. Yet my name's Huntington Kalunji, who is doing the demonstration. From which country? South of the equator. You're sinking inside those ones. Okay, let's take my notes. Northern. So UK, German, Sweden, Canada. In the sink, in the toilet. Should go club. That's how the Coriolis is possible. Now we have to prove it at the zero.
Prove it at the zero.
Where there is no anti.
I want to see it at the zero. Just
It doesn't spin on the equator.
It's gone.
Amazing.
And that's the exact reason why we see those currents as we do in the ocean, in the air, causing our ecosystems to be as they are. I think it's very interesting to understand all of this. There's other things that we have to take into account. You see here the altitude, of course, is important. The altitude and latitude, we already discussed that. And then there is another effect, which is also very, very interesting. And we see this. This is typically what we see between Monterrey and Saltillo. What happens is, this is the Gulf of Mexico. Here is Monterrey. Monterrey is all humid and lush and the Huasteca and green and stuff. You come to Arteaga, you come to the Sierra Madre Oriental. And then here on this side is where you have Saltillo. You know, it's on the other side of the mountain and it doesn't receive the rain anymore. And this is what we call a rain shadow. And that's also typically why the Atacama Desert is on that side of Chile and not on the other side. It's because sometimes in the spin of the earth and the ocean currents that it brings in the humid air, but all the rain falls on one side of the mountain. I don't know if you ever went to Puebla. You can also see this rain shadow effect very clearly in Puebla. But you can also see it really nice here in our own very city, because I don't know if you ever went to Los Lirios. There is like a really nice road from Saltillo to Los Lirios, and then you can drive to Santiago and Monterrey through the mountains, and you can see this. It goes from desert to coniferous forest, and then as you go down, you see the ecosystem changing. And that's what I really like about Mexico. Have you ever been to Cañón del Cobre in Chihuahua? You should go. It's really, really beautiful, because on top of Cañón del Cobre, you have like this coniferous forest, and you can hike inside this canyon for 1,000 meters deep. And really what you see, if you go in the Cañón del Cobre, you start here, and you in the canyon down there, it's almost a tropical scrub forest, and there is papayas growing, bananas growing, and on top it's really cold and it's only pine trees. And you just walk down into the canyon and it becomes better and better and better weather. So it's very fun, and I challenge you to do that. So this is it. What I wanted to explain for today, how ecosystems are formed. This presentation will be shared with you, but of course you don't have to study it. It has a lot of nice information, and it really explains all kind of ecosystems we have on our planet, with kind of vegetation you have, what are the characteristics, and what kind of animals are there. You don't have to study that in detail, but you have to know a little bit that coniferous forest is pine trees, and you have to know what a tropical rainforest is. But I will never ask men, give me 3 animals of the jungle or something. That's not the idea. You don't have to study these slides. This is in fact informative. Okay, so that's it for today, guys. I wish you a happy afternoon, and we see each other tomorrow for our last class, which is basically doing some activities about the Darien Gap. And then, yeah, then that's it for this week. So see you tomorrow.
Thank you.
Thank you.
Thank you, teacher.
Teacher.
Tomorrow.
Bye, take care.
Thank you, Mr.